So this tutorial is designed to get you up to speed, give you a general overview of DataJoint's element event. First, to talk about the kinds of data we're interested in, this element is designed to ingest trialized or event-based information from a given recording session. So we link to session, we find some notion of a behavioral recording, and then we break that down into blocks, trials, and events. So blocks in this case are optional. It's a way of grouping trials together optionally. Trials are also optional. Trials have a start and a stop time. It is some window of the recording session that you're interested in. And then events as the lowest level within this hierarchy are required if you're going to use element event. They have a start time, and then you can also be interested in an end time, but that's also optional information. So an event might be something instantaneous. A button press, you can consider the time that that button was pushed as the event you're interested in. Or it could be something continuous. Perhaps you have a kind of button that allows for continuous information about how long that button was pressed for. The element itself provides this diagram in the README. For more information about how to read these diagrams, I'd invite you to look at our quick start guide. With that information in mind, you'll see some green manual tables here where we expect manual insertion of information followed by part tables and computed tables that will ingest data from CSVs in the context of this workflow. Turning first to event, that's really our starting point. We can describe a behavioral recording with optionally some start time and recording duration. But really the main feature here is the set of events with start times. These events can be further categorized by type. So a button push versus lifting a lever. Those can be two types of events that maybe happen in the context of your experiment. To link this with trial is to provide more pieces of that hierarchy. So here, as I described, we can have blocks with start and stop time, as well as trials and trial types. Blocks can be associated with a given trial. So this is to pair a block with the trials that took place during that block. And then trials can be associated with events. So for a given trial, what events took place during that trial. The one interesting table of note here in element event is this event alignment table. This projects events from your event type table to correspond to start and end of windows that you might be interested in. So for a continuous electrophysiology recording, how much before a given event do we want to look at the data, and how much after when we're trying to identify perhaps some spiking or local field potentials associated with current certain types of events. Turning over to our workflow demonstration, we've added a couple features to workflow array ephys to demonstrate how to incorporate element event into an array ephys analysis pipeline. So this is just an example. You could add an analysis in for a number of different things, but in this case, we're attaching the event and trial tables here to a couple different analysis tables that will, through the computation in the spikes alignments process, help us align spikes from curated clustering to the example event data available in this workflow. So the notebook downstream analysis will help you get a sense of how those things get paired together. Here, as always, we're moving up one directory to get access to our config file and then importing the relevant schemas. That, in this case, is session, ephys, trial, and event. Unique to this workflow is the analysis schema with the tables that will perform the computations about the relative time window. So in addition, we have a new feature in this workflow array ephys ingest script, an ingest events function that takes a number of different CSVs here. So events, trials, blocks, some fake data along those lines, as well as an alignment CSV to ingest that window we described earlier. And I'll show an example. So adding a number of events to this table, we can take a look at the trials. Notice there are multiple trial types: stimulus, control, trial start times and stop times. These are always going to be recorded in seconds with respect to the onset of the recording itself. Here in the trial event table of element event, we can see a pairing of these trials with the events. Here in the example data, it's center, left, and right button presses. And then for this particular example, I'm restricting to trial IDs below 5 to really capture that, there were 2 center button presses over the course of trial 1, for example, 2 left button presses over trial 3. This is a function also in the ingestion script to take information from this alignment CSV and ingest it into the alignment event table. In this example, I'm taking the 5 seconds before and the 5 seconds after the center, left, right button presses and ingesting into that schema the notion of the window with respect to those events. So here to pair that with the ephys data that is demonstrated in these other notebooks, we're taking a clustering key to identify a particular subject and session and probe insertion, and pairing that with some of this example trial data. So in the case of this data, subject 6 has each of these trials for this particular session. We can see trial types, stimulus, control, as well as their respective windows. This cell here restricts to the control condition, and then within the analysis schema, we'll be identifying spikes that align to that, or will be identifying spikes within that condition. So alignment name, center button, for this trial condition, control trial, center button event, and then inserting that into the spike alignment condition table, inclusive of all of the trials associated with that spike alignment condition. The result is that we get a row in this table for each of the trials that satisfy those restriction conditions. So center button, and then a control trial. What this offers us is the ability to then look at the particular spikes that occurred in the course of that window. So spike alignment condition trial, here we're adding a secondary or second comparison, so the stimulus trials as opposed to the control trial, stimulus versus control, and demonstrating that we can pull the same information in each case. So to generate this parastimulus histogram, we'll need to run a populate command on the spike alignments table to essentially clip those windows and ingest each of the spikes and bin them in the context of that histogram. To visualize that, we provide this raster plot function. It's not pretty in the case of this fake data, but it gives you an example of how to pull from a continuous stream in element array ephys and align it with trial information coming from element trial. Comparing stimulus and control. So as always, please leave your questions in the comments. I'll be happy to respond to them. I'll include more links in the description to go in more depth on each of these topics. Thanks.